y colon equals 42.
Okay.
And then we can print y. And it prints it out.
Right.
And if I wanted to get the address, we use ampersand. And ampersand gives us the address. So that is where 42 is stored. Okay?
Right.
So it's an address in memory. And we could see the value that's stored there with just y. And we could see the address where that value is stored with the ampersand. Okay?
Gotcha.
So that ampersand is an operator. That's an operator. And then finally, if we have an address, we could dereference that address with another operator, which is the asterisk. Okay, so here we have the value. Here we have the address where that value is stored. And then we've taken that address and we've said, show me the value there. So those are both operators, okay?
So when you do that, when you dereference it, does it then free up that space in memory, or is it still there in memory?
Yeah, no, it's still the value is still stored at that address.
Okay, but you're just basically putting that operator in front of it saying dereference it. I don't want to see the memory address, I want to see the value.
Yeah.
Yeah. Okay.
And so this is a pointer to an int right here. And actually y is an int, and this is giving us the address of y stored there.
And in Go, you don't have to specify int. Like it knows it's int.
Yeah, it's dynamic figuring out the type, dynamically figuring out the type.
Okay.
So we could also do, so you got all that, right?
Yeah, I'm with you.
The reference and the dereference.
Yep.
We could have also done var y int, y equals 42, and that would have been the same thing we did before. Or we could have said, I don't know, just trying to think of var x as a pointer to an int, and x is equal to the address of y. Okay, so we could have also said that. And so let me just leave this one like that.
So wait, so question here. So why, when we do var x and then you do the dereference operator and then int, why is that? I don't. Am I looking at that correctly? Is that the same operator that we're using to dereference?
That's a great question. That is not an operator. That is the type. That is the type. So that's a pointer to an int. So that just means this is a pointer.
Okay.
That means here you've got a value stored here. You've got a value stored here, which is an int. So it's a pointer to an int. And y is var y int is just an int.
Right.
Okay.
So, okay, hold on. I want to make sure I understand the distinction between those two. So var y int is basically declaring y to be an int.
Correct.
And then var x pointer to an int, basically it's also declaring x to be an int, but it's pointing to a memory address.
No, those are two different types. This is an int. This is a pointer to an int. Those are two different types, just like string and bool and int are all different types. An int and a pointer to an int, two different types.
Two different types.
So for y wants an int, so I give it an int. X wants an address where an int is stored.
I got you. So there's no way to basically print the value of pointer to an int because it has no value other than the memory address. Is that right?
No, it's got the memory address, so let's look at that. There's the memory address. And I could dereference what's in that memory address. I could say, show me the value at that memory address.
Okay.
And when I do that, 42.
Oh, it's 42 because we assigned it to be y. I got you.
Yeah.
Okay. I got you. Okay, I'm with you so far.
That's it.
That's it. I understand everything now.
It's not any more complicated than that.
Okay. I think that was probably my biggest confusion, was that understanding that a pointer to an int is a different type, and we're not using the operator there. Yeah. I was thinking that we're using that operator again, and I didn't quite understand that.
Yeah, that's a common misconception. So that's a type, pointer to an int. This is an operator.
Okay.
This is an operator.
Okay.
Like a plus sign, minus sign. It's making that value do something.
Okay. Thank you so much for your time. I don't want to take up too much of your time. I really appreciate it.
The last thing I'll show you is, let me just copy this. And I got to make it smaller. So there's that address. And I'll drop that into Hangouts. So you have a copy of that.
Oh, okay, cool.
And now, last thing I'll show you is if you had a func, and this is delta, changes it and takes z int and says, you know, z is equal to 43.
Mm-hmm.
And so then if we did so we have y is 42.
Mm-hmm.
We print out that 42 and we get it. Mm-hmm. And then we pass y into here, so it gets assigned to z. Z, we set it equal to 43. And then we print y. So this is passing in the value, right? Y right here, the value 42 gets passed in and assigned to z. And then we just make z equal to 43. That's it, does nothing. And then we come back up here and we do that. So that's sometimes referred to as pass by copy. Okay,
yeah,
so
that's the other thing I didn't quite understand is why is it not 43 and why is it 42?
Why isn't that y right here 43? That one?
I'm sorry, you're kind of breaking up a little bit here.
Why isn't line 9 printing out 43? Is that what you're asking?
Mm-hmm.
Yeah?
Yeah.
So 42, right here, we pass in y, which is 42.
Right.
And then that gets assigned to z. The scope of z is right here. So we increment z and make it 43, but that's only happening right here. Y, the scope of y is right there.
I'm not seeing where you're pointing here.
You don't see it on your screen?
Mm-hmm.
The scope of y is func main.
Okay.
The scope of z is func delta.
Got it.
But if I pass in the address of y, and I say that z takes a pointer to an int, that's the type, I have an address here. So now I want to take that address and say the value at that address is 43. I have changed the value at this address, which is the address where y is stored.
Mm-hmm.
So now when I run this and I get the value at that address, right, which is what y is asking for, it's going to be 43. Because I passed the address here, and I said the value at that address is 43.
Okay.
I've shared memory between functions. I've accessed that memory where y is stored, and I've changed the value there to 43. So when I now print out y has been mutated. It's been changed.
So when you don't set z to a pointer to an int, then it gets that 43 gets then I still don't quite understand.
So when
why.
it's like this, it's just getting a value, not an address. And then that value is assigned to Z in delta Z, and it only lives in that function.
In that function.
That's the only place that lives.
Func main is it because func main is, it's sequential? Like when we're running the code, it goes through func main. Well, then it calls delta, so it still has to come down and look at func delta, right? But then I remember now from an earlier lesson you did, that value is only lives within that function. So it doesn't get, I remember.
Yeah.
It doesn't get carried on to the other functions. I remember you kind of went over that.
Yeah, man. It's a little tricky. Takes a little time. Takes a little time to wrap your head around. Just look at those examples I've pasted and play with it, and you'll get it.
Okay. No, it makes sense. It makes sense. I'm coming from Python, so it's a little new to me.
Yeah.
Yeah. All right. Thank you for your time, Ty. I really appreciate it.
Cool, man. You're welcome.
I was gonna tell you, like, I know a lot of people using Facebook Live these days. It'd be kind of cool, maybe for your other students, if you did like a Q&A session, like a regularly scheduled session or something. I don't know. Just an idea.
What's Facebook?